So we want to continue on doing row reduction and solving linear systems of three equations and three unknowns. So we're going to work this one with a matrix all the way through. We will call, so just a little recap. Remember, we can interchange rows if we want, which we probably will here. We can do a constant multiple, so like maybe dividing out by constant to solve. And the one that's takes a lot, but we can do that is to multiply any row or column by a constant and then add the rows together and then place it back into row. And that's like adding equations together, basically. So we're going to call these rows. We're always going to say row 1, row 2, and row 3, like that. And first thing we're going to do is just swap the first two rows, and then we will kind of talk about that from there. Our goal is to put these lower left-hand corner in as zeros. So basically do these row operations so that this lower left-hand corner is all zeros. Okay, that's called row echelon form. Okay, so our goal is to get it into what's called row echelon form. Okay, so let's just swap those rows and we get this. Okay, so we're going to swap row 1 with row 2, so you can indicate what you're doing to help figure out what's going on. So it's 2, 3, negative 1, 7, and 0, 1, negative 3, negative 5. So that 0 right there is what we want. Right? We want 1, 0 there, so we need another 0 here is the next order. So you have to do this in this certain order. So put a 0 there. We're going to do, we're going to look at these, well, let's just keep writing. So we go and put it down. So 4, 5, negative 2, 10. Okay. So now let's look at these rows, and if we do, so recopy row 1, that's not going to change right now. Put in your bracket, so it's 2, 3, negative 1, 7, 0, 1, negative 3, negative 5, like that. And so for row 3, we're going to do, look at right here, so you look above, multiply this by negative 2, and you get a negative 4. And you're going to add it to row 3. When you add those two, you get a 0 here. And then the rest just fall out of whatever it happens. So you tell me what you're going to do. Tell the reader, right? So negative 2 R1 plus R3. That gives you 0, negative 1, 0, negative 4. And go through that carefully. I did that fast, but just multiply each row by row 1 by negative 2 up here, and then add it to this row. So that'd be negative 6 gives you your 1, negative 2 gives you 0, right? And you go all the way down. All right, so we have our zeros here, which is what we want. Now we got to get a 0 here. So recopy row 1, 2, 3, negative 1, 7. Recopy row 2, 0, 1, negative 3, negative 5. And this will be a 0, 0 once we're done. So you say what you're going to do next. Okay, to do that, you just add them, right? Now you have row 2 plus row 3, and that gives you a zeros. So you get a 0, negative 3, and negative 9. And we have just reduced it to row echelon form, where here's are your lower triangular matrix of zeros. Okay, so that's what we call row echelon form. Okay, so then what you can do from here is back substitute to solve. So we say back substitute to solve. So what this means then is, remember this is x, y, z, and your constant. So what that means is negative 3z equal to negative 9. And then you can solve for z. Z is equal to 3. And then back substitute. So go back to this equation here. Well, let me show you. Go back to this equation to solve for your y. And once you get y, you go back to the original equation to solve for your x. So you have then y minus 3 times z, which is 3, equal to negative 5. So y is equal, so that's 9, and add, and you get a positive 4. Then go back to the original one, so that's 2x. Well, the first row. Go back to the first row here. So it's 2x plus 3y minus z equal to 7. But then you put in your variables you just solve for. So it's 2x plus 3, oops, let me fix that. So it's 2x plus 3 times y, which is 4, minus z, which is 3, equal to 7. Then you solve that for x. So you get 2x plus 12 minus 3 equals 7. 2x plus 9 equals 7. 2x equals negative 2. So x equals negative 1. So then you have your unique solution of negative 1, y is 4, and z is 3. There we go. Now, what you could do is keep going. So this is what I want to show you next. So what we can aim for is what's called reduced row echelon form. So over here I'm going to write it out. So this is what we call reduced row echelon form. What that looks like is 1 0 0 0 1 0 0 0 1, and then you have your constants a, b, c off to the side. So you can keep going in that manner, but work on the upper triangular zeros. So you can work on these to be zeros. Once these are done, don't change anything, and that's supposed to be a 1 there. All right, so this is what you can do. So we'll look at, let's see, I think I just recopied it. So go ahead and recopy the matrix that we have above. So it's 2, 3, negative 1, 7, 0, 1, negative 3, negative 5, and then 0, 0, 1, 3. Oh, I went ahead and did that there. Yeah, okay. To make this simpler, I went ahead and multiplied that by that constant. So I did negative 1/3 row 3. And put it right there. So we can see from here, if I do negative 1/3, that's a 1. And then that becomes your 3 right there, your 3. Okay. So now we want to get the upper triangular to be zeros. So you want these to be zeros now. So with row, let's see. Let's see where we're at here. So if we do, oh, there it is. Okay, so the simple one to do is row 3 and row 1. If you just add those together, you put a 0 there. So we're not going to change at this point ever row 3. So that remains the same. So you can write this in like this as 0, 0, 1, 3. And just say row 1 plus row 3. And then doing so, you'll get 2, 3, 0, 10. And then similarly, row 3 plus row 2, spend some time looking at this, 0, 1, 0, 4 is what you get. And so now we want to make this entry a 0. And by doing so, you can do -3 row 2 plus row 1. And then that'll be a 0. So this is your general procedure of how you would do it. -3 row 2 plus row 1. You get 2, 0, 0, -2. And the rest are already done. So you just recopy. And then look at your solution. Well, it's almost done. And then your last step is you multiply by that half. So you just do 1/2 row 1, and you get 1, 0, 0, -1, 0, 1, 0, 4, and 0, 0, 1, 3. Like that. And look at your solution. Okay, so your solution, as we did above, is sitting right there. So right here is your solution if you continue like that. All right. So you rewrite your solution, -1, 4, 3. So this is called reduced row echelon form. So this technique is called Gauss-Jordan elimination. That's the title. And we do this until we get reduced row echelon form. So what I usually do on the test, which will just be the final at this point, is I only require row echelon form. This up here. Okay, so this is what I require. But if you want to really practice and do it well, you get it to this form. Okay, so there's try this example. I'll give you the solution later. This is number 50 on page 573. Okay, so it's 2x minus 8y plus 54z equal to -4. X minus 2y plus 14z equal to -1. And x minus 3y plus 19z equal to -3. That's a 4. And the solution in the book is -171. So we'll double check that, work through that and see what you get before we go on to 6.2.